Transformations of functions. Basically starting with a basic function that we know about already from our toolkit and then moving it around by attaching a number in a particular way. So the first thing is vertical shifts. If we attach a number to the entire function, say we add a number or subtract a number from the entire function, then it's going to either move up or down. If we're adding, it moves up. If we're subtracting, it moves down. Now, if we attach a number directly to x, like group it in with the x, it's going to be a horizontal shift. However, it kind of works the opposite direction we think it should. If you have x plus 2, instead of moving to the right 2, you actually move to the left, and vice versa for subtracting a number directly from x. Okay, the next one are reflections. So whenever we attach a negative in, it's always going to mean some sort of reflection, or flipping the graph either vertically or horizontally. Now again, this kind of follows that same pattern. Attach a negative to the entire function, it's going to be a vertical reflection. Attach a number directly to x, we call it a horizontal reflection, like left and right. For vertical stretches and compressions, this is whenever we're multiplying by some number. The entire function is multiplied by some number. Now, if it's a number bigger than 1, then it's a stretch. It's like taller and skinnier. If, however, it's a number between 0 and 1, it's a compression. The whole graph looks like shorter and wider. If our number that we're multiplying by is less than 1, then it could be some sort of combination of both a vertical stretch or compression, but it could also be a reflection. Right? If it's below 1, it's a negative number. That would also be a reflection. So let's talk through a few of these and see what they look like on a graph. So transformations, the first thing here. If we start out with the x squared graph, nothing's been done to this. So let's use this and move it around to get our additional graphs as we go. So the first one I notice on the right-hand side, x squared plus 3. So we're looking at x squared plus 3. We have a value attached to the entire function, so that's going to be some sort of vertical movement. In this case, because it's added, we would move everything up 3 units. So the entire graph is going to get picked up, moved up 3 units, and set back down. So to do so, I'm going to go ahead and copy this, put it over here. So it looks the exact same right now as the x squared, but we pick this entire graph up and go up 1, 2, 3 units, and set it back down, and that's going to be our transform graph. A little bit different when we have x squared minus 4, but pretty similar, right? This is 4 being subtracted from the entire function, so it's going to be vertical, but in this case, because it's subtracted, everything's going to get moved down 4 units. So again, I'm going to start with our original. I'm going to go down 1, 2, 3, 4 units, let's say. I'm going to label my axes just so we're very clear this is at -4. But it's the exact same original starting graph, just picked up, moved down 4. Now it's a little bit different. Again, when we go over to the right-hand side, j of x is the quantity x minus 2 squared. So this time the minus 2 is attached directly to x or grouped with the x, so I know that's going to be some sort of horizontal movement. In this case, it does work the opposite direction we think it should. So since it's subtracted, this is actually going to move everything to the right 2 units. So I'm going to start with my original. Let's paste this back down. Nope. Paste it back down. Work with me, iPad. And I said we were going to move to the right 1, 2 units. Now you may be thinking to yourself, I don't know. Doesn't feel like it should move to the right 2 units. Well, let's think about that point that's on the x-axis. All right, sometimes we call those x-intercepts. All right, and what we should know about all x-intercepts is the y value for each one of those points is going to be 0. All right, so y value being 0 is basically equivalent to us saying the whole function is equal to 0. So if I wanted to locate that x-intercept, I would put 0 in for y, or in this case it's j of x. And let's think about how would you solve this equation. Well, the whole right-hand side is raised to the second power. It's raised to an exponent, so let's apply a square root to both sides as an inverse operation to that square. This will give us 0 on the left-hand side, x minus 2 on the right-hand side, And by adding 2 to both sides, we're going to get positive 2 for our x-intercept. So hopefully that helps you kind of believe that it actually is supposed to move to the right instead of to the left. Okay, next let's take a look at a few of these negatives. So k of x in this situation is our x squared graph, but we have a negative. And this negative is attached to the entire function because this is not the same thing as negative x squared. That would be the case where the negative was attached directly to x. In ours, it's attached to the entire function, so this is going to be a vertical reflection. So that x squared graph, all of the y values have become negative, and it's going to face downwards like this as opposed to the original that faced upwards. It's still going to have a highest point here, in this case at 0, 0, the origin, but the whole thing's been flipped upside down. One more, let's think about L of x, which is the square root of negative x. All right, you may think to yourself, okay, that square root of x, hopefully we start remembering what that looks like based on our function toolkit. And you can only plug in non-negative values into that function, so I'm going to graph it on the left-hand side. It sort of has this look going to it. All right, where it starts at 0 because the square root of 0 is okay, but you can only plug in positive values off to the right. If you try to plug a negative value like -1 in, the square root of -1 is not a real number. Okay, so in our case, we're going to start with that as our basic starting graph, but we have to apply this transformation. That negative is attached directly to x for L of x, so that's going to be a reflection, but this is going to be a horizontal reflection. So what that does is it's going to reflect all the points that are on the right side over to the left side. So it's going to take our graph, and instead of shooting off to the right side, it should look the exact same, it's just shooting off to the left side. Mine's a little bit off, but you get the idea, I hope, for how these work. Now it takes a little bit of practice to get used to how transformations work. But this is one of those skills that we want to keep developing because it really is handy when we're trying to visualize what a graph is going to look like if you understand these basics for transformations.